Good morning, my YouTube viewers. It is Crystal here, and I'm going to be doing a code review on exponential distribution. But before I go over the code, I wanted to talk about exponential distribution so you know a little bit about it when you're going over the code. So, looking on Wikipedia. So in probability theory and statistics, the exponential distribution is the probability distribution of the time between events in a Poisson point process, i.e. a process in which events occur continuously and independently at a constant average rate. It is a particular case of the gamma distribution. It is the continuous analog of the geometric distribution, and it has the key property of being memoryless. In addition to being used for the analysis of Poisson point processes, it is found in various other contexts. The exponential distribution is not the same as the exponential families of distribution. This is a large class of probability distribution that includes the exponential distribution as one of its members, but also includes many other distributions like the normal, binomial, gamma, and Poisson distributions. So that's what we've got about the exponential distribution. So now what we're going to do is we're going to cover some points that we're going to be covering in the code. One of the things is cumulative distribution function. And that's something that we're going to be using. And so we'll look here. The cumulative distribution function CDF is a probability distribution contains the probabilities that a random variable x is less than or equal to x. And another thing we'll be going into is PPF. So the percent point function or inverse cumulative distribution function, the graph on the left denotes that for a given x, the respective CDX value is input to the PPF function, and PPF returns once again the original value. The graph on the right is essentially the CDF graph above with the inverse. So that's what PPF is, and so we're going to be using these in our code, and that's why I wanted to discuss it. So we went on to a YouTube video, and I've got these questions from the YouTube video. I can show you the YouTube video that I got it from. So I got it from this YouTube video, the Statistics and Probability full course. I got it from that YouTube video, just so you'll know where I got it. And we've got some questions on exponential distribution questions. The first question is, the time between when I fill my bird feeder with seed and when Chunky the squirrel starts eating from the feeder follows an exponential distribution with an average time of 10 seconds. In other words, if we define t as the time in seconds until Chucky rates the bird feeder, t is distributed as exponential brackets L equals 1/10. What is the probability that Chunky waits at most half a minute before chowing down on some awful seed? And the answer to that is PEXP brackets 30, because that's 30 seconds, and rate is 1/10. So, because t equals t to the exponent L equals 1/10. And then so the answer to that is 0.95. That's the probability that he waits 30 seconds, or waits at most half a minute. Okay, so the next one, we've got 3 questions in this one example. The time I wait until the Gold Express bus comes follows an exponential distribution. My average wait time is 5 minutes. In the cold of winter, it takes 10 minutes for frostbite to start. Given this, what is the probability that I will get frostbite before the bus arrives? And then T to the exponent L equals 1/5. So the answer of the probability that you'll get frostbite before the bus arrives equals 1 minus PEXP, and it's 10 for 10 minutes, and rate is 0.2, which is 1/5, and that gives you a value of 0.135333. So now what it wants you to do is it wants you to calculate the median. So that's Q equals EXP brackets 0.5 because 0.5 is the median, and rate is 0.2 because that's 1/5. And the answer to that is 3.465736. Now it's asking you to calculate the 90 percentile. So that's Q EXP brackets 0.9 for 90 percentile, and rate is 0.2, which is 1/5, and so that gives you a value of 11.51293. So what I did was I translated this code into Python, and it wasn't, I had to do research to do it, especially with the median and the 90%, because it wasn't easy to find, because obviously I'm new at statistics and I'm definitely new at probabilities. So we had the first question, which was the bird feeder question or Chunky the Squirrel question. We had to import scipy.stats and use, so from scipy.stats import expon. So the answer to that is expon.cdf, x equals 30, that's 30 seconds, and scale equals 10, so that's 10 seconds. And so you had a value of 0.951 or 21293. So if you look over here at R, it is the same. So even though it's a different code, it still gives you the same result. Now we go over to the bus question. And the first question is, what is the probability that I will get frostbite before the bus arrives? And T to the exponent L equals 1/5. So the answer to that is 1 minus expon.cdf brackets x equals 10, that's 10 minutes, and scale equals 5, which is 5 minutes. And the answer to that is 0.135335, which is the same answer that you got in the R. And then the next question is calculate the median, and that's expon.ppf 0.5, which is 50%, and scale equals 5. And they gave you an answer of 3.465735902, which is the same that you got in R. And the next one is calculate 90 percentile, and the answer is expon.ppf bracket 0.9, which is 90%, and scale equals 5, and that gives you a value 11.5129254. And so that's the same as what's in R. So even though Python went about finding the answer a different way, it still got exactly the same results in Python that we got in R, which is what we want to see. So now what you can do is you can decide for yourself what you like better. Do you like Python or do you like R? I think R probably is perhaps a little bit easier to use, but I'm used to using Python. I'm totally new to probability, so I'd have to study probabilities a while to actually be good at these probabilities functions. But I'm going to go ahead and conclude this video because I've answered these probability questions on exponential distribution. And I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you very much for watching this video. I look forward to making more code reviews for you in the future.